the New Zealand Tech Podcast, brought to you by Gorilla Technology, proactive and strategic IT.
Hey folks, greetings and welcome along to the New Zealand Tech Podcast. Today I have the privilege of catching up with Martin Sharrock, Chief Technology Officer at 2degrees. Welcome, Martin. How are you?
You're right, Paul. Thanks for inviting me.
Great to have you here. It's been a rather disruptive time this last few weeks, and so we were hoping to catch up a couple of weeks ago, but there's a bit of a cyclone, and cell sites that got knocked out, and there were all sorts of dramas. Of course, some of the country is very much still impacted by that. You were showing me a photo just before we started of a road that has been wiped out between, I think, Napier and Taupo, where it's like the road's gone, but that's also taken fibre with it. So there's really has been some pretty significant disruption to New Zealand's telecommunications on a scale that we've never really seen before. Would that be fair to say?
Yeah, look, it's been an unprecedented time. What I do want to do is, just before answering the question, just to call out the people on the ground. We've had 16 or 17 days of preparation and then storm response and then restoration of fiber networks and mobile networks. And it's not just the telco people on the ground, people providing accommodation, people providing cars, people providing logistics. It's been a huge, huge national undertaking by so many people in New Zealand. So, I've been up here in the control center at 2degrees in the operations center, but so many people have been down there on the ground, making a huge difference for New Zealand, putting things back together. It's been massive.
Yeah, look, I think all of New Zealand appreciates the efforts that have been going in across the board. Before we sort of, jump in to everything, a big thank you to our show partners for keeping New Zealand Tech Podcast operating. So thank you to Gorilla Technology, HP, Spark, 2degrees, and Vodafone. Lovely to have 2degrees as part of the support for New Zealand Tech Podcast. I think, there's a lot to talk about in terms of, what's been happening within the world of 2degrees. There's also, so much I think we can delve into to understand, what has happened in a disaster scenario, what the learnings are for the future.
Yep.
There, I guess, have been big changes, internationally, in terms of the role of Huawei, and of course, 2degrees network has started out with Huawei technology, and now moving ahead in another direction. So there's probably some interesting aspects in terms of how that looks. Rural broadband, ultra fast broadband, lots of things.
So much.
Let's start sort of delving into how big was that impact of Cyclone Gabriel. I think last week we referred to a figure that had been passed on to me, possibly partway through the restoration of the mobile cell sites, and I think we talked sort of 6 to 7% of cell sites nationwide being knocked out. But when we were chatting earlier, you said that number could be a lot higher, maybe as high as 10%.
Yeah, at the peak. Just rewinding, obviously, this was the third event we'd had within just a few weeks. We had the storms before Christmas, we had the storms in January, and then this unprecedented Cyclone Gabrielle coming through just a few weeks ago. And it really was an unprecedented event on the scale we haven't seen, obviously, for many years, certainly from a telecommunications perspective. The one good thing about a weather event is it's coming. Unlike tsunami potentially or earthquakes, a weather event is coming. And it did therefore give us several days to actually prepare the team, prepare on the ground for what we knew was about to happen for New Zealand. You've heard many stories about generators, about satellite links, etc. And as 2degrees, 2 or 3 days in advance, we were moving generators to the places where we thought they'd be most needed. With generators, you need fuel. With fuel, you need personnel and people to look after them as well. We actually accelerated some of the preparation in the lab. We were looking at how could we potentially get cell sites back online if we had problems with fiber, for example, from a backhaul perspective. And the main tactics we used were microwave radio and then ultimately satellite links as well via Starlink. So all this was happening before the winds even started, and it felt quite surreal on the Thursday and Friday to be doing this kind of preparation in the calm weather before the storm pushed on through on the Sunday, Monday, and Tuesday. The other unique thing, generally this kind of catastrophe is localized, localized to a particular town or a particular city. We all obviously remember vividly Kaikoura and Christchurch.
Yeah.
This event was not localized. It started in Northland, it pushed through Auckland, it pushed down through the Waikato, and then on, as we know very much, through the Hawke's Bay and into Gisborne as well. So we were actually logistically moving people, moving equipment, moving generators down the country as the event actually matured over 4 or 5 days.
In terms of your upfront, view on how big the disruption, might be, did you have much of a feeling? Did you have an inkling it could have been at this sort of scale from the modelling? Was it, because these things move around and change, you don't really know until it happens, right?
Yeah, I mean, we run scenarios, and generally, if you're an operational executive and you have a good operational team, you tend to run the far right scenario more than you run the far left. So we were thinking, what happens if we take down multiple fibers? All fiber networks generally on the main paths around New Zealand are on diverse paths. And the kind of scenarios we were running is, what happens if we lose both or all three diverse paths to many of these sites? What happens if we can't get the crews to the cell sites quickly with respect to generators? All cell sites have batteries, but they only last so long. So we were running the far right scenario of, what if we can't get to these cell sites for 6 hours, 12 hours, or even 24 or 48 hours? So I think the answer to the question is, we were thinking far right well in advance.
Yeah, well, it certainly, it was. I think probably, from that, the telecommunications impact, perspective must have been at the very, far end of the scale in terms of how bad things, could have been. Are you, left with any, and I don't know if enough time's gone past yet, but, any thoughts on how things would change, in the future to, considering that, we're expecting there's going to be, more incidents rather than, less from a weather perspective, in the future. And of course, you've now had to deal with a pretty major, hit at a really large scale. Do you think that will lead to some differences and some changes? And of course, part of it that you were able to leverage, you mentioned, Starlink, that wouldn't have been a practical option when most of these cell sites were purchased, right? So things, the technology that facilitates things has been changing over time.
Yeah, I think you could split it into things that work well and things that we could potentially improve together, both as a company and as an industry, and also generally across New Zealand. I mean, things that work well. The telecommunications industry is well known for being fiercely competitive, but at times like this, we're fiercely collaborative. So it was a really good collaborative environment between 2degrees, Spark, Vodafone, Chorus, and many of the suppliers that we had on the ground. So don't change anything there. Collaborating together, working together, using each other's resources, helping each other get connectivity back for the good of New Zealanders. Like, for example, we got mobile connectivity back relatively quickly into Gisborne by using some microwave connectivity, but then we got it back on fiber. And by doing that, we allowed the 111 service, the 111 service, to be used by anyone in the area. We all have fiber networks, and generally pretty quickly we can share them if someone gets their link up faster than somebody else. So, lots of collaboration going on across the industry. Other things that worked pretty well, cell sites held up really well from a physical infrastructure perspective. If you consider that the power infrastructure had many problems with respect to resilience, the actual cell towers themselves did not break. They didn't fall over, they didn't blow over. Generally, they weren't flooded. So the infrastructure held up pretty well. So, what generally we had problems with was access to the cell sites, being able to get there with a ute, with a generator, with technicians, etc. And then the fact that power was out for a very, very long time was one we have to work on in the future. It has actually probably increased a little bit of the innovative work that we were doing and all the telcos are doing in the background. You mentioned Starlink. What we have been working on in the lab is actually being able to use a generator and a business grade Starlink set. We don't use the consumer grade. Why not? I mean, the business grade actually contains more CII, more committed business grade bandwidth that we can use.
You can get more data across.
More data.
More calls.
It also includes a more sensitive, higher quality antenna. So we can actually get better quality for the backhaul rather than just for one particular customer. And it also includes a native Ethernet adapter as well, so we can plug it natively into a cell site. So we started working with these business grade SatLink systems from Starlink several months ago, and actually nobody wants a catastrophe, but the ability to get that system on the ground, get it configured, and prove it has been actually quite instrumental in probably helping these kind of disasters in the future. In fact, we still have one of those systems on the ground in Wairoa, and we've left it there deliberately, taking advantage of the fact that, number one, the fiber infrastructure is still a little bit tenuous in the area, so we wanted to make sure we kept it on the ground. And secondly, to soak it, to understand it, to study it, to look at the stats, to take 1 or 2 weeks to really see what that means from a customer experience perspective for a cell site on the ground. So, to answer your question, we would continue to improve that kind of last line of defense telecommunications solution, test it in the field, test it in the lab, and really make sure that next time, we've got about 10 of these Starlink systems, and we've got over 50 generators that we keep around the country. So we could actually deploy systems a little bit faster in the future. Now we've actually gone through the innovation curve.
Yeah. Oh, that's helpful. So it's not, I guess there's so many cell sites, and there's always, I guess, that sort of balance in terms of investment, and it could be a long time before any one site goes down, that you wouldn't be at the point at this stage of wanting to put a sat link on every sort of cell site. That wouldn't be a practical sort of thing at this point.
Yeah, it's interesting. I mean, Cyclone Gabrielle was a once in 100-year event, and previously we think we found the sweet spot with respect to battery life, for example, on cell sites between 4 and 8 hours. Generally, you can get to a cell site within 2 or 3 hours.
Yeah.
You can place a generator there if you need to. Even more than that, generally you can fix the fault, or the electricity company can fix the fault inside 4 hours. So ecologically as well, you don't really want to have piles and piles of batteries at 5,000 cell sites all around New Zealand, actually, all the time. So you've got to find the sweet spot with respect to battery power. The satellite question is interesting. I mean, generally the reason the cell site goes down is power rather than backhaul. Most cell sites are fiber fed. Certainly 2degrees cell sites are. We built ours from 2010 to now, and that's been during the generation of UFB and during the generation of fiber. So we've really taken advantage of fiber at 2degrees cell sites. Highly reliable, unlikely that it goes down and causes an outage. So generally it's power. So as long as the batteries are working, we find the sweet spot at the time for the batteries. Under normal circumstances, it should be good. It's just, we need to think hard about when we have these extraordinary climate-driven events like Cyclone Gabrielle, what extra can we do quickly to get connectivity back? And that's the satellite link Starlink scenario we just talked about.
Yeah. Okay. Oh, that's fascinating. Now let's talk about changes in the network. You're going through a transition of sort of modernizing the technology and across all your cell sites. How is that sort of different to maybe what some of the other networks have been doing? This is sort of part of your move to 5G. What does that look like?
Yeah, I mean, generationally, 2degrees started building the network in 2009, accelerated through 2010 to 2013 and onwards. So, the network is now over 10 years old in many places. And 2 years ago, we started to renovate the network. We made a decision that we would actually renovate from the ground up. So the big difference is that every cell site we upgrade, we actually take away all the equipment that was already there, and we turn on new equipment from a new supplier. We're using Ericsson, who are supplying Telstra in Australia, so very good credentials, and the performance has been borne out here in New Zealand through network testing. What we've actually done is every cell site we've been to, we've turned on every carrier of spectrum that 2degrees has: 700 megahertz, 900, 1800, 2100, and of course 3500 megahertz, where we've got 5G new C-band allocation of 80 megahertz of spectrum. So we've really been going full out to make sure that if we touch a cell site, if we close the road, if we have to do any physical work on the ground, we've actually done a complete upgrade and turned it into something much better than it was before. We started in the main cities. I mean, if you go back to 2degrees history, the first places we built the network was Auckland, Wellington, Christchurch, and Queenstown. And we've actually started in the main cities for the renovation of the network. And now, if you drive through downtown Auckland, if you drive to downtown Wellington, Christchurch, you will actually see you get a good contiguous 5G experience on the 2degrees network. What we've also done is, because we've only got one vendor or one supplier for all 5 layers of the network, it allows us to do something called dynamic spectrum sharing. It means that as 5G becomes more popular, more proliferated, devices are what's driving 5G uptake, both mobile devices and wireless broadband devices. We can dynamically allocate spectrum 5G and 4G right across the cell. Right now, the capacity layer and the biggest layer of 5G spectrum is the 3500 megahertz. And we've been using some amazing technologies like MIMO technologies, beamforming technologies to get some amazing data rates actually down through the cell sites. You can actually walk through downtown Auckland now and get real life user speeds between 500, 600, up to the best one I've seen is about 870 megabits per second through a 5G aggregated with 4G mobile connection, which is unprecedented from a few years ago. So, we've been doing customer walks down in Wellington, walking people through how we've built the network, where the network is. Sometimes it's quite hard to see the cell sites. We do tend to hide them away a little bit, but we've built a multi-layered network in the city centres to make sure no matter where you are, down at street level, in your car, in an office building. I think we got a performance of about 370 sat inside your office building here in Auckland. So we're tremendously proud of what we've done, and the job forward from here is we're approaching quite a few hundred cell sites that we've actually swapped already, and the rest of the job for the next couple of years is to do the rest.
Yeah, that's exciting. And so at the end of this, does this puts you in a position where you've got a full Ericsson network, and Huawei is that's gone?
Yeah, I mean, obviously, just to break the networks down, all 3 operators have just over 400 cell sites that we share between us. So from an outside-in perspective, thinking rural, we're exactly the same. We've all put money in together with the government and built the Rural Connectivity Group network, which is over 400 sites, covers tourist hotspots, highways, rural New Zealand, and really does start to fill in those gaps that would basically not spots in the future, and helps with public safety and helps with coverage in rural. So that's exactly the same. The rest of the cell sites, obviously, from a 2degrees perspective, we have a couple of hundred that we share or co-locate. 2degrees spectrum, 2degrees network, 2degrees experience, but we share the towers and we share with Vodafone. The rest of the cell sites, which is over 2/3 of them, are actually owned, operated, built, upgraded, maintained, operated by 2degrees. And the objective is, over time, that we'd swap all of those cell sites for brand new cell sites.
What does the selling off of the cell towers, how does that impact anything from your perspective?
Yeah, obviously you've seen in New Zealand that all 3 mobile operators have now actually sold or offered to sell the physical infrastructure. Obviously, from a 2degrees perspective, we have to wait for Overseas Investment Office and Comcom clearance, but the precedent has been set, so we hope that goes through as expected. What have we sold, first of all? We've sold the physical concrete. We've sold the steel that the cell sites sit on. But for example, the power at the site, the ancillaries on the site, cabling, antennas, etc., all the active equipment on the site, microwave radio, radio access network from a cellular perspective, all still belongs to 2degrees. So we have full influence over the technology we use, the capacity we have on the cell sites, and what we've done is we've sold the physical towers and the physical concrete. And we're hoping that, from a New Zealand perspective, obviously with all three companies now having divested that part of the business, we're going to get lots of synergies where we can bring that physical asset together and we compete at the network electronics level and the network experience level.
Yeah, that's really interesting. Now, what else is going on? On the network, front for you. Are there any other things that folks would be interested in?
Yeah, so much. I mean, obviously people think of 2degrees and they think prepaid mobile, maybe, from the past, but we really are a full service telecommunications provider now. We've recently, as many people know, gone through a merger with Vocus Communications as well. So that brings into 2degrees over 4,200 kilometers of actual physical fiber up and down the country. So we're a fiber provider. It's an interesting marketplace because now you've got Chorus, you've got Vodafone, you've got Spark, and you have 2degrees all actually having fiber in the ground, providing connectivity, not only up and down the country, but in the big cities as well, providing business connections. So providing data center connections as well. We all connect up to the hyperscalers, we all connect up to the international cables, etc. So it's become quite an interesting marketplace. Now we're on a level playing field with the competition. Obviously, we're going through a big integration exercise as well. We've got the assets from Vocus and the assets from 2degrees. So we're going as fast as we can, bringing those together, bringing us advantages. It means we have more network, we have more sites, we have more data centers, but also we have efficiencies as well. Where we have duplication, we're working quickly to try and migrate and bring together the network asset as well.
Yeah, there's certainly a lot going on there. You mentioned the hyperscalers, and we've got Microsoft and AWS, and I guess everyone will be benefiting in New Zealand, from largely, I guess there's a few folks probably not so keen if they've got somewhat competing local hosting and so on. But with that move of the big players into the New Zealand market, what does that look like? How much sort of connectivity do you need to put into to connect up with them, and what are the other pieces that people might not know that are interesting?
Yeah, I mean, even just stepping back from a micro view, the amount of data, the amount of content, and the amount of compute that's actually happening on the ground on New Zealand soil has been increasing for many years, even before the hyperscalers have made the decision to come to New Zealand. The percentage amount of traffic that we actually go offshore now to collect for our customers is becoming smaller and smaller. You're into the 20% rather than 10 years ago it would have been much higher than that. From a 2degrees perspective, we're not here to try and compete with the hyperscalers, but we do have some unique credentials that we can bring to the marketplace. We do have data centers on the ground, and we host many customers who want to be near to the international cables, near to the hyperscalers. We do connect to them, and also near to the internet peering exchanges. So our sweet spot is securely, reliably, resiliently hosting business customers and giving them the connectivity they need in the big cities around New Zealand.
And can you talk to what sort of connectivity that you put in with to the hyperscalers?
Generally, we're providing fiber connectivity. Yeah, I mean, we're connecting our data center to their data center. I mean, the whole of New Zealand is connected together by fiber these days, and our objective is to make sure we've got available, reliable fiber connectivity into the hyperscalers. It means our business customers can very, very easily attach their applications and their networks to when they require to the hyperscalers.
Yeah, and I mean, how fat are those pipes, as we might say? I mean, I guess you've got that flexibility to sort of scale them over time.
Yeah, I mean, it's fascinating that a fiber pair these days can carry 8 or 9 terabits per second. So we're not actually constrained as much by the actual fiber itself. And when you're just going a short distance, 2 streets away, or a few kilometers across Auckland, the fiber really isn't the constraint, because you really can turn on a heap load of bandwidth when you're actually connecting across such short distances.
Yeah. And I mean, we look at New Zealand's international connectivity. I know when we started doing the New Zealand Tech podcast, it was a little bit worrying, actually. There wasn't too much international connectivity. I think we had the Southern Cross, and that was pretty much it. Obviously, things have grown a lot since then, and there's a fair degree of resiliency, but things happen of varying sorts. How comfortable do you sort of feel with the level of connectivity that we have as a country, and do you think there's still a bit of a way to go to give us I guess, I don't know if you can ever get to complete peace of mind that we couldn't get cut off from the rest of the world, but
I mean, the fiber connectivity has significantly improved from where it was 1 or 2 decades ago, for sure. We've got the Hawaii cable, you've got the TGA cable, you've got the 2 Southern Cross cables. It makes a big difference. Obviously, we can plan our network connectivity and resilience based on using all of the different cables. Then, of course, you've got the fiber connectivity, not only internationally, but across the Cook Strait. So we have to make sure that we've got good diversity going from Wellington, going from the Kapiti Coast, actually down into South Island as well. So I think, look, I mean, you can never have enough international cables to different diverse points, especially when we have the kind of weather events and catastrophes that we have had in New Zealand. It's good that we're looking at a consortium's looking at bringing a cable down to the bottom of South Island, which will help. Which will help a lot.
Good.
Yeah. And we'd certainly be open to consortium or joint ventures that would actually improve the fiber connectivity between North Island and South Island.
So what is there at the moment in terms of that connectivity
between South and North Island? I mean, obviously we've got transpire cables. We've got cables that go across from 2 cables that go across from Wellington to Blenheim, and we've also got a cable that goes across from Nelson into the Kapiti Coast, and there's an older cable that goes down the East Coast as well, that goes into Kaikoura and into Christchurch. So there is diversity of cable, but maybe some aging cables in there as well. So obviously, it would be interesting to actually collaborate together as an industry and think about how we can improve both capacity and diversity across the Cook Strait.
Yeah. Now, looking at the role of ultra-fast broadband in New Zealand, the fibre rollout, you mentioned how when 2degrees started building a network, it was at the time where the UFB rollout was kicking off, and so you've been a beneficiary of that and able to sort of tap into to the UFB. Previously, you were with Chorus and amongst other roles you've done there. I think did I see the Ministry of Defence or something in the UK going back a few years as well. So some interesting things. But I guess you've had quite a close view and close involvement on UFB in New Zealand. What have been your learnings and observations? Sometimes we sort of look at Australia versus New Zealand, how they've gone, and hey, it just looks a lot better at this end. But you probably know a fair bit more technically than most on it. What have been your observations?
I've probably got 2 unique lenses on UFB, having been part of Chorus and quite proud of being part of the team that put UFB together after the separation of Chorus and Spark. So that was a huge amount of work to get the machine rolling and to actually make that project successful. 87% of New Zealand homes can now access UFB, which is a massive undertaking. And when you compare it to Australia, as you suggest, it's a big advantage for New Zealand. I believe the uptake's now at 71, 72% of people that can connect. So a tremendously successful project. So for someone who was part of Chorus, I think it's been a tremendous project. I think it's been really good for New Zealand. It's improved communications. If you look at the recent weather events, the fibre network actually held up pretty well. The mobile networks held up pretty well, apart from those areas where we lost the fibre connectivity. And the copper networks didn't hold up so well. So, it really does prove how the investment in fibre has been a good one. If I take my lens now as CTO at 2degrees, we use the fibre networks a lot. We use our own fibre network to backhaul from cell sites to transport nationally, but we also use the UFB network as well. The vast majority of our broadband customers use the UFB network, and we shouldn't underestimate how capable the UFB network is. On an international standards and use case perspective, if you look at a GPON network, gigabit passive optical networks, generally it takes one fiber and it splits it into many, many other fibers to feed individual homes and businesses. And internationally, the number of splits on that fiber could be 64, 128, or even 256 splits per fiber, i.e. one fiber being shared out between many, many, many homes and different customers. It was quite visionary, actually, of the people, including CFH and Chorus and others at the time, to actually specify a really low split ratio in New Zealand. So actually, all of our fiber networks have a 16:1 or a 24:1 split ratio, which is very, very low on an international standard. So it means that our networks are much more capable. And from a 2degrees perspective, it means that we use it very well for business customers. And we also use it a lot for mobile cell site backhaul as well. When you've got such low split ratios, it means you can get more capacity. It means you have more reliability as well. So it's been, I think personally, a fantastic project for New Zealand. Reliable broadband into people's homes, reliable broadband into businesses, and really good telecommunications use of the fiber asset as well. You mentioned that 2degrees, we built our network alongside UFB rollout, and as a result, we've got a very high percentage of fiber-fed cell sites versus microwave radio-fed cell sites. There's definitely a place for wireless broadband, and there's definitely a place for other kinds of broadband, but fiber obviously is a tremendous asset when you actually when you need to use lots of data in the home and in the business.
Yeah, definitely. I think we're incredibly fortunate on that front, and I think that it'll keep paying dividends in all sorts of ways for a long time to come. Obviously, there's all sorts of other differences in terms of New Zealand versus Australia in terms of
they'll catch up.
How things have played out, but it's a really has been an amazing position to be in. Now, what about sort of the this move to 5G? That's obviously a journey for all networks in terms of getting to 5G, and then I saw some online things, and of course Mobile World Congress happening in Barcelona. So 6G ends up sort of getting thrown around. I think there was something out of maybe it was sort of South Korea of a 2028 goal to get for them to get their first sort of 6G network up. But really, there's a lot of work ahead, isn't there, in terms of getting 5G out there, and then getting the most out of 5G, and it tends to go through. It's going to go through a lot of iterations and changes over the years ahead.
Yeah, I mean, even if you don't mind, I'll take the G's out of it in the first part of the answer, and say there's only really three things that allow you to add capacity on a cell site. That's the number of cell sites you deploy in a particular area. The other one is the amount of spectrum you have. And the third one is how efficiently you actually use that spectrum. And actually what 5G is doing is it's giving us more spectrum. We mentioned earlier on 80 megahertz of brand new 3.5 gigahertz spectrum. So that's fantastic. And the second one is it's much more efficient than other technologies from a bits per second per hertz perspective. You're 15, 30 bits per second per hertz across 80 megahertz means that we can get a lot more capacity down through a 5G cell site than we can through a 4G cell site. And we need that as a nation because the growth year on year of mobile usage is running around about 42% on our network, and I believe something similar on the other networks as well. So, in 2 years, you're almost doubling the amount of capacity that you need in the network. So first and foremost, 5G is the solution to add more capacity in the future. It's doing that in many ways.
It's not just about the individual sort of connectivity, per person, because I think it's easy to fire it up and go, I got, as we did before, 300 plus megabits per second sort of down to your mobile device and think, I don't need that much at my mobile device, but we've got to look at it from that bigger picture perspective.
I mean, 5G is tremendously good at giving you very high capacity when you need it without interfering with other people. The other thing to realize with mobile networks is we transmit more data, but you don't want to interfere with the next cell site. So what 5G does really well, and it's technologies like multi-user technologies and spatial antenna technologies and beamforming technologies, actually allows us to send the data just in the direction of the actual device that needs it, rather than to everybody in a particular cell. Most devices now have 4 antennas within them. A cell site with a 5G antenna normally has 32 antennas, 32 small little base stations in any 5G antenna, and it's tremendously flexible in how those antennas can actually point the data streams in different directions for the use of individuals. And it means you can put the power and put the transmit and put the data in a particular direction, but it means also that you're not putting interference in another direction. So it is quite a clever technology in how you can actually have data where you need it, interference where you don't need it.
And what is the sort of typical utilization of these cell sites? This idea of being able to focus in a particular direction. I think when we first heard about these sort of beamforming type technologies and say home Wi-Fi type environments, like it sounds cool. And thinking of it in a cell site context, you're thinking, hold on, there's a lot of people potentially using a given cell site. Even more so if you're, I don't know, at a sports game or somewhere where there's a lot of people all at once. What do you see from that perspective, and how useful are those technologies when you've got lots of people about?
Yeah, I mean, obviously essential. I mean, we mentioned earlier on that we've built all 5 layers of every cell site that we've replaced in Auckland, Wellington, and Christchurch. And that's the first way that you actually manage the capacity. That's the spectrum part we were talking about earlier on. And then you're using technologies we talked about, like beamforming, to make sure you get the most out of the spectrum. And then 5G actually has a higher data rate than 4G, for example. I have a map on my PC here, what we use in the office, and actually all of the 2degrees cell sites in central Auckland and central Wellington are now completely green and ready for usage and ready for capacity to be allocated to customers after that renovation. So really future-proofing the network at busy hour. The only time that really matters for us telco professionals is busy hour. We don't care so much about how used the cell site is in 4 in the morning or even perhaps 12 p.m. in the afternoon. The busy hour between when the school kids leave school to when people are putting their phones down in the evening and stopping using Netflix around 9, 10 p.m., that's the part that really matters.
And so looking at that, what's the role of fixed wireless, using the mobile network to to connect to home, a business, or what have you, rather than tapping into fiber? Obviously, fiber is not available everywhere, but there's also, I guess this aspect where you want to generate, as every network, naturally would. You want to, generate as much from your network asset, as you can. And yes, you were previously at Chorus, but I'm sure, you want to, get the most out and not be, paying out too much off to the likes of Chorus.
Yeah,
right?
I mean, to be realistic and pragmatic in the answer, it's about choice.
Hmm.
If a particular customer has a wireless broadband device, be it 4G or 5G, maybe there's data caps, maybe it's unlimited. Depending on what they need, that can provide a really good broadband service that can support Teams calling all day. It can support the Netflix movie in the evening without any problems at all. I mean, for example, in my house, I use fiber most of the time, but I will swap to a 4G and 5G modem just to experience what the difference is and just to experience how it feels to be using that network. Certainly working from home, using Teams, using video, doing email, no difference whatsoever. Watching a movie in the evening on a 4G wireless connection, no difference whatsoever. Maybe the only time there's a tiny difference is when I've got one teenager watching movies, I've got another teenager on the Xbox, I've got my wife watching TV, I'm working upstairs, and maybe there'll be a little bit of an issue, not an issue, but maybe a little bit of a degradation then. So I guess what I'm saying is it's about choice. Unless you're the kind of person that uses 1, 2, or 3 terabytes of data every single month, and you've got 3 or 4 people in the house who use a lot of data, you're probably okay with wireless broadband, provided we do our jobs as telco CTOs and make sure that you've got enough capacity, you've got enough coverage, and we're putting those devices in the right places in the cellular network.
Yeah, I mean, I think we're pretty sport in New Zealand that we have these choices, right? So we've got fibre, which if it's practical and it's available to use, then it's unbeatable and in just about every regard. But look, actually, if you can get 4G or 5G doing a well, suits your needs, and you've got some advantage, whether it's price or flexibility to take it from your home to a batch or another scenario like that, then that can stack up quite well.
Yeah, there's like you suggest, there's many reasons to have wireless broadband. It could be because it's your batch, it's your second connection. It could be because you're price conscious and you don't want to pay quite as much as you would do for a fiber connection. But 71% of people who can get a fiber connection have connected a fiber connection, which gives you an idea of the fact that it performs very, very well.
Mm-hmm. How do you see things sort of playing out with Starlink? It's a premium price, and of course SpaceX can twiddle the knobs, as I see they have been doing on some of their plans and so on recently. I think their RV rates are going up, and other bits and pieces. Do you think now that that's been in the market for a little while, that things will be reasonably settled, because their performance might not necessarily change a lot, certainly in the short term, but no doubt there's going to be more and more 5G available in rural areas?
Yeah, look, I mean, I think it's about choice and it's about necessity. I mean, for example, we're using Starlink business grade products, and they are several $100s to buy and several $100s a month in subscription services.
Yeah,
so your average consumer really doesn't want to pay for that kind of grade of service. Often the reason why people are attracted to wireless broadband is it's less than a fiber connection. Starlink is in fact significantly more than a fiber connection to pay for per month. So it almost becomes each product to a particular use case or a particular marketplace. Certainly wouldn't not recommend using a Starlink solution in a remote rural location where you can't get good wireless broadband. Our business team is currently promoting Starlink as well, because we want to make sure that our business customers can get a ubiquitous connection, a ubiquitous service no matter where they are. So we're actually using Starlink sets out there with business customers to connect branch offices and to connect customers where they need to as well. So look, I mean, it's another tool in the toolbox. I'm absolutely certain it's not going to replace fiber. As you know, it's the gold standard, and I'm absolutely certain it's not going to replace 4G or 5G wireless broadband where the service is good enough.
Yep. And where does 5G sort of fit in on the fixed wireless front? Because it's been quite pricey to put to buy 5G devices for a home and so on. Where does that sort of fit for you on the network at this point in time?
Yeah, I mean, obviously, I pay for the network and I buy the network and I rely on my product colleagues to put the right price in the marketplace. But the cost of a 5G fixed wireless service is actually tremendously competitive when you consider how capable it actually is. From my perspective, it's, I wouldn't say worryingly so, because we've got a heck of a lot of 5G capacity, but I really do think that we're going to be supporting many more 5G wireless broadband connections on the 2degrees network.
So the and I'm forgetting the term, I'll just say router. So the 5G routers are now at such a level, because it did seem to be a challenge to purchase those in the past. So it seemed like it was always 4G really being used for sort of fixed wireless.
There's competing factors at play here, because we've got an inflationary marketplace where component prices have gone up in some instances and supply chains have been constrained. So that actually is maintaining prices. But at the same time, the manufacturers are starting to produce in volume. They're starting to get smarter in how they actually produce the devices and the components they use. The sizes are getting smaller. So actually, the price, the input price is actually coming down. Perhaps not quite as fast as we would have liked it to, but it is getting more competitive the more we actually put into the marketplace.
Okay. Not too much else that we're going to be able to squeeze in, but eSIMs, that's something you've supported for for a while now. How's the uptake? How you finding that in terms of how often are people using eSIM? And probably the other bit, which is sort of attached to that, is it does seem to be technically sort of a challenge to support the likes of Apple Watch and so on. Are you able to share a little bit about that?
It's becoming more popular. I mean, you obviously heard rumors and noises in the marketplace about some devices actually going eSIM only. So it's definitely the way the market is going in the future. We obviously support both SIM-based and eSIM-based devices. And we've seen more eSIM activations coming on board every month that goes by. We've been using it in some innovative ways. Like, for example, we've been offering trials on the 2degrees network. We can activate the SIM on the device without actually having the need to send a SIM to a customer. So, we're thinking about more innovative ways that we can actually use it. I mean, for example, I've got 2 connections in my phone. We do some partnerships with Vodafone and Spark, and we actually swap SIMs or swap connections and make sure we've always got a couple of connections on our devices for emergency situations, for example. With respect to wearables, working hard in the background, wearables, it's not just the network, it's the back-end systems as well, to be able to support them and support all the applications and voice and data and interconnectivity, and make sure that they can work independently when you're out and about away from your phone. So watch this space coming soon from 2degrees.
Oh, that sounds exciting. That's great. Well, we've covered a fair bit of ground, actually, Martin. It's been great. Anything else you think that we should be delving into?
Look, covered everything from the cyclone to network build to 5G to UFB to everything, really. I mean, obviously 2degrees is 13, 14 years old, growing, getting stronger and stronger by the month. And from a network perspective for myself, we really are investing to make sure that we're not catching up with the competition anymore. We're up there on a par with the other guys. So really investing, focusing, and working really hard to make sure 2degrees customers get the best possible experience.
Yeah, look, I mean, that was something that I probably, we covered off when Mark Callender was in last year, and I've been, doing a bit of comparative, testing as I've been around the country over the last, few months with a 2degrees connection alongside my Vodafone and Spark connections, and I've actually been, pleasantly surprised with. That it almost feels, like, certainly the different, spots I've been in, having been on, road trip around varying parts of the South Island through areas like the Catlins and so on, and the like that, if you're not going to have connectivity, you can't, you can't predict, as maybe you might have been able to in the old days, as to which network might be up or down in a particular area. In fact, I mentioned the Catlins. I think there was a chunk of driving there where there was no network, and there will be places like that. But with the work with the Rural Connectivity Group, of course, that's improving all the time, isn't it?
Yeah. Look, I mean, probably, to be honest, 4, 5, 6 years ago, if you'd wanted the best performance and you'd wanted national coverage, you probably wouldn't have chosen 2degrees. It's a completely different world today. We've got the most modern network in the city centres, and that's expanding obviously to other places around New Zealand this year and next year. Brand new equipment, really utilising 5G to the max in those areas. You mentioned ICG. The playing field is exactly the same in rural areas with respect to that network that we've all built together. So, part of the issue we have as 2degrees is just cut through to hearts and minds for people to believe that we actually have an equal, if not better, network in some places than the competition.
Yeah. Well done on all the work. And look, it's great to have a situation in New Zealand where, from a telecommunications perspective, things are competitive, and everyone's working very hard to bring their A game, I suppose. And I think everybody benefits from that. And I'm really curious how things sort of play out over the next few years ahead, but long may the competition continue.
Yeah, look, it's an amazing industry, and last plug, if anyone wants to come work at 2degrees, amazing company, amazing culture, amazing technology, get in touch.
Yep, actually that does bring me, I should just squeeze in around the merging and bringing Vocus and 2degrees together.
Sure.
How does that go? I think one of the things that we looked at with Vodafone, they had varying sort of acquisitions and so on over the years, and quite hard to sort of merge all the technology systems together. How does that look for you? And is that a big long road ahead to really make things seamless, and to, I guess, get rid of sort of legacy systems so you can standardize everything on one system?
Yeah, I mean, I think I'd use 2 words: unrelenting fast. No, I mean, seriously, not just myself, but my colleagues in the company as well. Our number one focus is to bring the 2 companies together as fast as we possibly can. We know that if you don't do it now, and you don't do it fast, and you don't make it your priority one, it will never happen. So we are unrelenting as a team to get through the integration process from a network perspective, from a systems perspective, from a people perspective, from a culture perspective, having one company in 2degrees as fast as we possibly can. And, the boss was here, and, it's been a very consistent mantra that we are 2degrees going forward. That's our brand. And we're going to be 2degrees from one consistent network: fiber, transport, core networking, radio access networking, BSS and OSS systems, and so it goes on.
Oh, well, good luck with with the next steps there. Yeah. Excellent. All right. Oh, thank you so much for your time, Martin.
No problem. Anytime, Paul.
All right. Cheers. Thanks, folks. Thanks for joining us. And we
the New Zealand Tech Podcast, brought to you by Gorilla Technology, proactive and strategic IT.